So let's start with the first question from S1 May 2024 paper. And let's see what's the question number 1. The first question is about. So if I give a brief review of the background of the first question, this is basically the concepts behind this question is from chapter 2 and chapter 3. That is, chapter 2 is basically measures of location and spread of your statistics S1 book, and the chapter number 3, this is basically this is basically representation of what? Data. Okay. So in order to be able to solve this question, you should have definitely solved questions from chapter 2 and chapter 3 of your S1 textbook. So let's get started with the first question of May 2024 paper. Okay, so a researcher is investigating the growth of two types of tree, birch and maple. Okay, the height to the nearest centimeter as a seedling grows in 1 year is recorded for 35 birch trees. How many? 35 birch trees and 32 maple trees. Okay, the results are summarized in the back-to-back stem leaf diagram. Back-to-back stem leaf diagram below. Okay, what is a back-to-back stem leaf diagram? Definitely you have learned about stem leaf diagrams in chapter 3, that is representation of data. So in a back-to-back stem leaf diagram, there will be a single stem, like here. This is the stem. This is the stem, and on its either side there are two leaves, maple and birch. That's how it works. Okay, and how you can interpret this back-to-back stem leaf diagram? This is basically with the help of the key. The key says 5:6:3 means what? 65 centimeter for a birch tree, okay, and 63 centimeter for a maple tree. Fine. Okay, next, what they said next, the median height that these maple trees grow in 1 year is 45 centimeter. Okay, the median height, median is what? Median is basically Q2, right? Q2 is given as 45 centimeter. Okay, fine, we know the median. Fine. So they are asking to find the value of K used in the stem and leaf diagram in part A. In part A, they are asking to find the value of K. Okay, let's see what is K. Okay, K is basically which term? 5, 7, that is 12, 12 and 12, 13, 14, 15, 16. So K is basically the 16th term in the stem leaf diagram. Okay. Okay, so before asking for finding the value of K, they said what? The median height. That means we need to make some relationship with the median of the data. Okay, so let's make this relationship. For a data, median, like median, quartiles, these things depends on what? These quantities depends on the total number of data. So here the total number of data is how much? It is 32, right? It is 32. There are 32 maple trees. So n is 32 here. Okay, so n is basically even number, right? 32 is an even number. So for even number, what we know, the median is basically the what? Average of the middle term, and it's just the next term. Okay, so here the middle term is what? The 16th term, since 32 over 2 is what? 32 over 2 is 16, and its next term is what? Its next term is 47. So median would be the average of the what? Of the 16th term and the 17th term. So 16th term is what? How can you interpret the 16th term? Let's see. They said 6:3. 6:3. This is basically 60 plus 3. That makes it what? 63. So like as that, what we can say for 4 to k. So 4 to k would be what? 40 plus k. Fine. 40 plus k. So we got the 16th term. So let's consider the what? The median. Fine. So for part A, what would be the value for Q2? Q2 would be the 16th term. The average of the 16th term, that is 40 plus k, and the 17th term. What would be the 17th term? 17th term was 47. Yeah, 47 over what? Average. So 2. Fine. So 40 plus 47, that is basically 87 plus k over 2. This is equals to how much? What was the median? They said 45. Okay. Okay. So k plus 87, it is equals to how much? 90. So what would be the value for k? K would be 90 minus 87, that is 3. So we got the value of k. Done. Part A is done. Next, for part B, they are asking find the lower quartile. Okay, lower quartile is what? Q1, and the upper quartile, that is Q3, right? Upper quartile is basically Q3. Okay, upper quartile of the height grown in 1 year for these birch trees. So now they are asking for the birch trees. Okay, so for the birch trees, I said earlier that median, quartiles, these quantities represents, like, depends on what? On the number of data. So here there are total 35 birch trees, isn't it? There are total 35 birch trees. So since there are total 35 birch trees, so which is what? Even? No, it's odd. So 35 is odd. So if the total number of data is odd, then how do we consider the quartiles? Let us consider the lower quartile, Q1. So Q1 is basically what? The data which lies on the 25% of the whole data, right? So 21% is what? Sorry, 25% is what? 1/4. 25 over 100, that is what? 1/4. So 1 over 4 times n. So that would give you how much? 35 over 4. This is basically 8.75. 8.75. So you can write what? 8.75. Should we round up or should we round down? In this case, most of the students get confused. Look, in chapter 2, in quartiles part, it is clearly written, like, if the total number of data is what? Odd, then always you will get a decimal value for the, like, the, while finding the term, okay, number of term. So in that case, as you get the decimal value, you will always round up. It's clearly written. So we will always what? Round what? Up. So that is 9th term. So for 9th term, let's look for the 9th term from the stem leaf diagram. 9th term would be what? 2, 8. Okay, 2, 3, 4, 5, 6, 7, 8, 9. So 9th term is 3:9, that is 39, isn't it? 39. So 39 centimeter is the what? Is the lower quartile. Okay, 39 centimeter is the lower quartile. Done. Next, the upper quartile. Same method, but upper quartile is basically the 75%, that the data that lies on the 75% of the whole data. Okay, so this is 75% is basically 3 over 4 of how much? 35. The total number of data is 35. So what we will get? 3 times 35 over 4. This is 26.25. 26 point what? 25, which should be rounded up. That is 27th term, right? So 27th term is what? Let's look for the 27th term from the stem leaf diagram. 27th term is basically 2, 8, 10, 19, 2, 10, 19, and then what? 28. So 27th term is what? This one is the 27th term, right? Just before the 28th term. Yeah, so this is 57. So we got the upper quartile, that is 57 centimeter. That's it. So lower quartile is 39, upper quartile is what? 57. Done. Next. Okay, next what they said, the researcher defines an outlier as an observation that is greater than Q3 plus 1.5 times Q3 minus Q1 or less than Q1 minus 1.5 times Q3 minus Q1. Okay, so we need to show that, part C asks to show that there is only one outlier amongst the birch trees. Okay, amongst the birch trees there is only one outlier. We need to show that. Okay, so in order to show that an outlier, what we need to do, at first we need to find out the upper limit for an outlier and the lower limit for an outlier. So consider the upper limit at first. Okay, so upper limit would be what? For part C, at first consider the lower limit. Lower limit would be what? Lower limit is Q1. Q1 was what? What was the Q1? It was 39 minus 1.5 times Q3 minus Q1. Q3 is 57 minus 39. So lower limit is what? 1.5 times 57 minus 39. So that is 39 minus 27, which is 12. Fine. So that is 12 centimeter is the what? Lower limit. Okay, and then consider the upper limit. Okay, so upper limit would be what? Q3 plus Q3 is what? 57. So 57 plus 1.5 times how much? 57 minus 39 is basically what? 22. Sorry, it's 57 minus 39, it's basically 18. Yeah, 18. So what would be the upper limit for the outlier? This is basically 69. Okay, so wait, 1.5 times 18, that is 27. So not 69, it's basically 84. The upper limit is 84 centimeter. Fine. Now outlier would be if the data value is less than 12 or greater than 84. Okay, let's see. Let's look for any data that lies less than 12 and greater than 84. There lies, look, 8:5, right? Which is greater than 84. Okay, so what we can write? So there are no data what? Less than 12, right? But there are what? 85. There is a data that is 85 centimeter. It's what? Greater than 84 centimeter. Hence an outlier. Fine. Hence this is an outlier showed. Done. Okay, next is what? Next is part D. What they have asked in part D. Okay, the grid on page 3 shows a box plot for the heights that the maple trees grow in 1 year. Okay, so part D asked to draw a box plot for the heights that the birch trees grow in 1 year. Okay, we need to draw a box plot. Okay, for drawing a box plot, so basically the concepts of box plot you have learned in chapter 3 in representations of data. So in box plot, what we do actually, we represent the quartiles, right? Quartiles, range, outliers, and what? Yeah, we represent quartiles, range, and outliers. Okay, so we have all the quartiles, we know all of the quartiles, we know the outliers, we know the range. So just we need to draw the box plot. Okay, so what's the starting value? The starting value is what? Here it is 28, right? The smallest value is 28 without an outlier. This is not an outlier. 28 is the starting value. So the box plot, it's given, the grid is given here. So it starts from 28, right? 28. So 25. So 28 goes for here. So 28. So this is the what? Starting value. Okay, it will start from 28, and then from 28 the Q1. What we got the Q1? Q1 was 39, right? So it will go for 39 next. So this is 39. This is 39. Fine. And then the median. What was the median? Median was, do we know the median? Okay, no, the median is unknown. So median is basically what? N over 2. That is 35 over 2. Or N was 30. Okay, 35 over 2. 35 over 2 is what? 17.5. That is 18th term. So what's the 18th term here? So 2, 10. So 10, then 19. Right? So 19, 8. 18th term. 18th term is basically 48. Right? Median is basically 48. Okay, we got the median. That is 48. So 48, where does 48 is? 48 is here. So this is 48, the median. And at last, what? The upper quartile. Upper quartile is what? It was 57. Where does 57 goes? 57 is here. So this is basically the what? Upper quartile. Done. Now the upper range. The upper range is what? The upper range is basically, is this 85? No. Upper range would be the maximum data value, the highest data value without an outlier. 85 is an outlier, so upper range would be 76. The upper limit is what? Upper data is what? 76. Okay, it would be 76. Where is 76? Here. This is the upper range, 76. Done. Now just mark out the outlier. Outlier is what? 85. 85 is the outlier. So this is 85. So outlier would be what? Here. This is an outlier. Done. Now we just need to connect the boxes. Okay, just connect the boxes. Done. So this is basically the box plot. Fine. Okay, let's see the next, what they have asked next. That is in part D. So in part E, basically, yeah, part E. Part D done. Just the box plot. Okay, comment on any difference in the distributions of the growth of these birch trees. We need to comment on any difference, like in the distributions of the growth of these birch trees and the growth of these maple trees. Okay, so they said they have given a hint. State the values of any statistics you have used to support your comment. Okay, so we need to consider the difference, whether there is any difference between the distributions of the birch trees and maple trees. So let's see from the box plot. Can you like figure out any differences here? Yeah, definitely there are some differences like notable here. Look, for differences, like when the question asks for differences, we basically consider either the spread or the location. If you are considering the spread would be the range of the data, or the I keyword, that is interquartile range. Okay, these two things, like with respect to the box plot, these two things can be the, these two quantities can be the like measure of what? Spread. And for location, you can consider the median, because in a box plot we have only the idea about the median as a as a central tendency, isn't it? So we can say it's for 1 mark. So we can say either we can have a comment on the measure of location, or we can have a comment on the measure of spread. So which one you can say? Let's consider the measure of location. So measure of location, if you are considering the measure of location, let's consider the what? Median, right? So median for birch trees, it's what? It's 48, right? But for the maple trees, it's what? 45. So we can say that on average, birch trees has what? Taller lengths or taller heights, or you can say greater heights than maple trees. Yeah, since the median, like the median of birch trees, it's what? Greater than, that is 48 centimeter. Sorry, birch trees, it's what? 48 centimeter, which is greater than the median of the what? Maple trees. That's what we can comment here, right? So what we can write here for part E is that for part E we can write Q2 for birch trees, right? Birch trees is greater than Q2, that is how much? 45 centimeter. You can mention it. 48. Yeah, 48 centimeter for birch trees is greater than the Q2 for what? Q2 for maple trees. Fine. For maple trees, right? That was how much? 45 centimeter, right? Okay. So on average what? Birch trees grows taller, or you can say higher than what? Maple trees. Birch trees grows grow taller than what? Maple trees. That's it. Part E done. Okay. So next is what? We need to consider part F, the last part of this question. Okay. For part F, they are saying the researcher realizes that he missed out 4 pieces of data for the maple trees. For maple trees, the researcher has missed out 4 pieces of data. Okay. The heights each seedling grows in 1 year to the nearest centimeter in ascending order for these 4 maple trees are what? 27 centimeter, a centimeter, 48 centimeter, 2 centimeter. Okay. Given that there is no change to the box plot for the maple trees given on page 3. Fine. So due to these 4 missing data, the box plot of maple trees, it's not changing. This is very like conceptual question. So for part F, they are asking find the range of possible values for A. We need to find out the range of possible values for A. Now let's consider the concept. What's the concept here? Look, the first data that is missing, it is 27, and the third one is 48. Let's consider the 2 positions, 27 and 48. Where does 27 lies? Look, 27 lies here, right? This is 27, right? Which is before the lower quartile, right? This is 27, which is before the lower quartile. And then 48, which is basically here, which is between the Q2 and the Q1, right? Which is between the Q2 and Q3. Yeah, the median and the upper quartile. So they said the shape of the like the box plot will be not changing. That means that shape of the box plot is not changing. That means what? The position of the 4 data values would be at 4 locations. How? Since 1 is here, that is before the lower quartile, and the third one is between the median and the upper quartile, so that means the next 2 must be at this location and that location. That means above Q3, and the second one would be between the Q1 and Q2, in order to keep the box plot unchanged. Fine? Because the box plot, it depends on the what number of data, right? N. So if the 4 data values are at 4 locations, then their values will remain same. Okay, so let's consider the second. So that means the second one is what? A. Okay, for part F we need to show the workings. For part F, what we can say, A should be greater than Q1 and less than what? Q2. So what's the Q1? Q1 is basically 39, right? 39, and Q2 is what? 57. Okay, 57. But if you see the fourth missing value, the fourth missing value is basically twice of A, right? Twice of A. So if you consider twice of A, and if you consider the lower limit for A to be 36, then 36 times 2 would be 72, and if you consider the upper limit to be 45, sorry, 45. 39, it's for the what? It's for the birch trees. Okay, so Q1 here, the Q1 should be how much? From let's take the reading from the box plot. It is 36 and 45. Okay, it is 36 and 45. Okay, it should be 36 and what? 45. Okay, so if you see twice of A would be what? Twice of A would be 72, right? Twice of A would be 72. So twice of the upper limit would be 90. So that means twice of A would be what? Greater than 72, less than how much? 90. But 90 lies outside. The upper limit is what? 80, right? So that means twice of A should be less than how much? 80. Let's consider that. We need to write this, write this here. But what? Twice of A should be less than 80. So A should be what? Less than 40. Therefore, what we can write? Combining the two range of values of A, we can write A should be greater than 36, and it should be what? Less than what we can say? 40. Less than 40. If this is the scenario, then the addition of the 4 missing data will not change the shape of the box plot. Done. And that's all about the first question of Statistics 1 May 2024 paper. That's it. So let's see what's the question number 6. Question number 2 is about. So the question number 2, the concepts behind question number 2, it has been discussed in discrete random variables chapter. That is chapter number 6 of your S1 textbook. So in order to be able to solve this question, definitely you should have practiced questions from chapter number 6 of your S1 textbook. So let's get started with question number 2. So here they are saying a spinner can land on the numbers 2, 4, 5, 7 or 8 only. Okay, The random variable x represents the number that this spinner lands on when it is spun once. So x represents the number on which the spinner lands. Okay. The probability distribution of x is given in the table below. We can see the probability distribution of x. Okay. So the first part, in part A, they are asking to find probability of twice of x minus 3 greater than 5. So we need to find out that probability. So let's say for part A, they're asking to find probability of what? Twice of x minus 3. So we can write twice of x, take minus 3 to the right side, like solving an inequality, greater than 8. So probability of x greater than what? 4. So what would be that? Now let's see what are the possible outcomes greater than 4. That is 5, 7 and 8, right? So that would be what? 0.2 plus 0.1 plus 0.15. Okay, so 0.2 plus what? 0.1 plus 0.15. So what's that? 0.45. Yeah, so 0.45 is the probability of twice x minus 3 greater than 5. Done. Okay, next, what they have asked in part B, given that expectation of x equals to 4.6, the expectation of x is given. We need to show that the variance of x is 4.14. So basically, I think if you have done chapter number 6, then you were supposed to know the formula for variance, right? So variance is basically what? Variance of x is what? Expectation of x squared, right? Minus what? The expectation of x whole squared. This is the formula for variance of what? X. So expectation of x is given. We need to find out the expectation of x squared, right? So expectation of x squared is what? Summation of what? If I write expectation of x squared, this is basically summation of what? X times probability of what? X. Okay, sorry, x squared times, yeah, x squared. Since it is expectation of x squared, this is what? Summation of x squared times probability of x. That means x, each of the x values will get squared and multiplied by their respective probability. Okay, so let's do that. Expectation of x squared, we need the expectation of x squared. So for part B, we need the expectation of x squared. That would be what? The first term is 2, so 4 times 0.25. So 4 times 0.25 and then plus what? 16 times 0.3. 16 times 0.3, 4 squared is 16, and then 5 square is what? 25 times 0.2. 25 times 0.2. 25 times 0.2, and then what? 7 squared is what? 49. 49 times 0.1. 49 times 0.1, and at last this is what? At last this is 64 times 0.15, right? 64 times 0.15. So what would be the value for expectation of x squared? The expectation of x squared is what? 4 times 0.25. This is 1 plus 16 times 0.3 plus 25 times 0.2 plus 49 times 0.1 plus 64 times 0.15. So what you will get here is that 253 over 10. This is 253 over what? 10, which is 25.3 basically. So 25.3. We got the expectation of x squared. Now it's the time to find out the variance of x. So variance of x is what? Expectation of x squared, that is 25.3 minus what? The expectation of x whole squared, right? So expectation of x is given as 4.6, so that would be 4.6 whole squared. Okay, so 4.6 squared, so what would be the value? This is basically 4.14. so the variance is how much? 4.14. Done. So we got the variance 4.14 as per asked by the question. Done. 4.14 is the variance asked by the question. Done. Okay, next, for part B, the random variable y equals to ax minus b, where a and b are positive constants, given that expectation of y equals to 13.4 and variance of y is 66.24. So we need to find out, in part C, we need to find out the value of a and the value of b. Okay, so expectation of y is given as 13.4. okay, so y is again ax minus b. So since y equals to ax minus b, what we can write? Look, expectation of y can be written as what? Expectation of ax minus b. Yeah, expectation of ax minus b. So what we can write here, this is a times expectation of x minus what? B, right? Okay, so expectation of x is what? It's 4.6. so 4.6a minus b, right? So what we can equate, they have given the expectation of y, so 4.6a minus b, this is equals to how much? This is basically what? 13.4. this is 13.4. this is the first equation. Now second is what? Variance. So variance of y, so variance of y can be written as what? Ax minus b, right? So ax minus b can be written as what? Okay, variance of ax minus b, it's given as 66.24. okay, this is 66.24. okay, now variance of ax minus b, we know that for subtraction or addition, variance doesn't get changed, right? So only for multiplication the variance gets changed by the square of the multiple. So that means a squared times what? Variance of x. Basically y you can say y is basically a coded data for x. Y is basically a coded data of x. Okay, so for coding, basically if you multiply the data values by a constant, due to the multiple, the variance gets changed. The variance gets changed by the square of the multiple. Okay, so this is equals to 66.24. okay, so we got the value for a, we can get the value for a here. So a squared equals to what? 66.24 over 4.14, right? That's the variance of x. So what would be the value? 66.24 divide 4.14. so this is basically 66.24 divide 4.14, that would give you 16. That means the value of a is plus minus 4, right? So is it minus 4 or plus 4? Did they mention anything here about the value of a? A and b are positive constants. That means a is what? A must be 4. okay, now what would be the value for b? B would be what? B would be 4.6 times 4. 4.6 times 4 minus what? If you take b to the right side, just substitute the value of a into the equation. So 4.6 times 4 minus 13.4, that would give you 5. The value of b is 5. That's it. Done. Next, the part D. In part D, let's see what they have said. In a game, Sam and Alex each spin the spinner once, landing on x1 and x2 respectively. So the Sam's score is given by s equals to x1 and Alex's score is given by what? R equals to twice of x2 minus 3. The person with the highest score wins the game. If the score are the same, then it is a draw. Find the probability that Sam wins the game. Okay, we need to find out the probability that Sam wins the game. Okay, in order to Sam win the game, x1, the score of Sam should be greater than the score of what? Alex, right? Okay, so let's consider the cases. If Sam's score is 2, if x1 equals to 2, then what should be the Alex's score in order to Sam win the game? That would be what? If you consider if x2 is also 2, if x2 is also 2, then what would be the score for Alex? That is, R would be how much? R would be 2 times, that is 4, that is 1. That means Alex score is what? Greater than what? Sam's score is greater than Alex, so Sam will win. So this is acceptable, right? Next, consider if Sam scores 4. Okay, if Sam scores 4, and what should be the Alex's score? Okay, wait, x2, if you consider x2 that is 2, you are getting R equals to 1. If you consider x2 to be 4, then 4 times 2, that is 8. I'm considering the Alex score for x equals to 4. So 4 times 2, that is 8. 8 minus 3, that is 5. So it will get greater than 2. That's why let's ignore these values, like x2 equals to 4, 5, and so on. Okay, let's ignore these, because for these values of x, Sam will lost. Okay, Sam will lost the game. Okay, so let's consider what I said, x1 equals to 4. If Sam's score is 4, then what should be the Alex score to let Sam win? That means x can be 2 definitely, no issues there. If you consider x2 equals to 4, what would be the case? Let's consider the case. 4 times 2 is what? 8. 8 minus 2, that is 5. Still Alex is getting what? Greater. Sorry, yeah, Alex is getting greater. So 4 is not acceptable. Okay, so we got 2 combinations so far. x1 should be 2. Okay, x1 should be 2, x2 should be 2. Okay, second case, x1 should be 4, x2 should be 2. Next is consider x1 to be 5. If x1 is 5, consider x1 to be 5, and if x1 is 5, then definitely x2 equals to 2 is acceptable, because x2, if x2 is 2, then R is what? 1, which is less than 5, so definitely it is acceptable. But if you consider x2 to be 4, 4 times 2, that is 8. 8 minus 3, it becomes equal. Okay, it becomes a draw. Okay, so x2 equals to 4 is also not acceptable. We got another combination. x1 should be 5, x2 should be 2. That's what we need to do here. We need to separately find out the combinations. Then x1 should be 7. If x1 is 7, let's go up a bit. Consider x1 to be 7. Okay, if x1 is 7, consider x2 to be, definitely 2 is acceptable. Now 4 is also acceptable because 4 times 2 that is 8. 8 minus 3 that is 5. 5 is less than 7. I'm considering 5 is what? If you put x2 equals to 4 into R, the LX score, you will get 5. That means which is less than 7. So still Sam wins. Now consider x2 to be what? 5. If x2 is 5, then 5 times 2 that is what? 10. 10 minus 3 that is 7. It becomes equal, so it will become draw. So ignore this value. So we got another combination. 2 combinations we got. 7 2, okay, and 7 what? 4. Fine. Next, x1 is 7, and then the last one is what? Go up, x1 to be 8, and x2 to be what? Definitely 2 is acceptable now, definitely 4, and then 5 would be also acceptable because 5 times 2 that is 10. If x2 is 5, put it into the equation of R. 5 times 2 that is 10. 10 minus 3 that is 7. Still what? Less than 8. So we got 3 combinations there. 8 5, 8 4, and 8 2. Done. That's how we need to find out the probability. Fine. So for part D, we need to find out that probability that what? Sam wins, right? Sam wins. So what's that probability would be? So let's consider the probabilities. At first, x1 was 2, right? x1 2 and x2 2, right? x1 2, x2 2. That means probability of x to be 2, this is 0.25, so there is 0.25 squared. Okay, this is 0.25 squared, this is 0.25 squared, then plus what? Plus next is what? Next would be what? x1 should be 4 and x2 to be what? 2. So 4 and 2, that is 0.3 times 0.25. 0.3 times 0.25. Okay, that would be 0.3 times 0.25. Okay, 0.3 times 0.25. Okay, so 0.3 times what? 0.4. Next, plus. Okay, next is x1 is 5, x2 is what? 2, right? That is 5 and 2. Okay, 5 and 2. What's the probability? 5 and 2. 5 is 0.2 and 0.25. So 0.2 times 0.25. 0.2 times 0.25. Fine. Next is what? Next is x1 is 5, x2 is 2, x1 is 7, x2 is 2. Again, x1 is 7, x2 is what? 4. 2 possible combinations here. 7 2 and 7 4. 7 2 7 4. So 0.2 times 0.1, and then 7 4. So 7 is 0.1 times 0.3. So 0.1 times 0.25. 0.1 times 0.25 at first, 0.1 times 0.25, and then this is for 7 2, and then again what? 7 4, which is 0.1 times 0.3, right? 7 2 7 4, 7 2 7 4, yeah, 0.3. Okay, so and at last we got for what? 3 possible combinations, right? When Sam's score is 8, 8 2 8 4 8 5, 8 2 8 4 8 5. Why not 7? So 7 times 2 is basically 14. 14 minus 3, this is 11. It's getting greater. Okay, so that's why we ignored 7. So 82, 84, 85. So 82 is 0.15. Okay, 0.15 times 0.25. 0.15 times 0.25. So 0.15. We can add them up, right? 0.15 times we took common 0.25 plus 0.3 plus what? 0.15 times 0.25 plus 0.3 plus 0.2, right? 25, 0.3 and 0.2. Okay, 0.2 next. 0.2. Now you just add them up to get the final answer. So let's add them up. So 0.25 squared plus 0.3 times 0.4 plus 0.2 times 0.25 plus 0.1 times 0.25, 0.2 times 0.25, 0.1 times 0.25, and then plus what? 0.1 times 0.3 plus 0.15 times what? 0.25 plus 0.3 plus 0.2, which is 0.75. So 0.15 times 0.75. That's it. So the total would be we got 0.4. We got 0.4. Okay, so this is the probability of Sam winning the game. Okay, let's have a check whether our probabilities were fine. So the first one was 0.2522, right? 0.25 whole squared. That's why 0.25 whole squared. Second one was x1 is 4 and x2 is 2. Okay, 4 and 2. 4 is 0.3 and 2 is 0.25. Okay, 0.3 times 0.25. 0.3 times 0.25. It should be 0.25. Okay, let's correct it out. 0.25. Okay, so if it is 0.25, so 0.4, we got 0.4 earlier. So from 0.4 we can subtract 0.3 times 0.4. Earlier it was 0.3 times 0.4, so it is 7/25, and then add with that 0.3 times 0.25, so you will get 0.355. It's not 0.4, it should be 0.355, and that's the answer. Fine. Okay, so that's all about the second question from May 2024 S1 paper. That's it. So let's see what's the question number 10 is about. So basically the concept behind question number 3, it's from chapter number 2 of your statistics 1 textbook, which is named as measures of spread and location. Location and spread, measures of location and spread. So in order to be able to solve this question, that is question number 3, definitely you should have practiced questions and you should have gone through the concepts of chapter number 2 of your statistics 1 textbook. So let's get started with question number 3. Let's see what the question is about. What the question says: the lengths x millimeter of 50 pebbles are summarized in the table below. Okay, the lengths of 50 pebbles is given in this table. Okay, so length frequency, you can see there's one column for length and the next column for frequency. So a histogram is drawn to represent these data. histogram is don't represent these data. Okay, so the bar representing the class x greater than or equal 32 less than 36 is 25 centimeter wide. Its width is 25 centimeter and it's 7.5 centimeter tall. So the bar in the histogram of this data, the bar that is representing x greater than or equal 32 less than 36, it's what, how much width? 25 centimeter wide and 7.5 centimeter tall. Now the question asks in part A to calculate the width and the height of the bar representing the class x greater than or equal 30 less than 32. Okay, fine. So we need to find out the height and the width of this class x greater than or equal 30 less than 32. Okay, so at first consider, like we can do this using the unitary method, like 2.5 centimeter, it's for how many units? Like from 32 to 36, how many units are there? 4 units, right? 33, 4, 5, 6, yeah, 4 units. So for 4 units the width is how much? 2.5 centimeter, right? So 4 units width is how much? Width is 2.5 centimeter, right? So for 1 unit width would be what? 2.5 over 4, right? So what we need for how much centimeter? So for how many units? This is 30 to 32, that means 2 units. Okay, for 2 units width is how much? 2.5, that is 5 over 2 times 2 over what? Over 4. Let me write it separately since small place. Okay, so 5 over 2, that is 5 over 4, that means 1 point, how much? 1.25 centimeter. Okay, so width is how much? 1.25 centimeter. Done, we got the width. Next is what we need to figure out. We need to find out the height of the what? Bar. Okay, so how can you find out the height of the bar? Okay, look, the height of the bar is basically dependent on the frequency density, right? We know that on a histogram along the y-axis we consider the what? We consider the frequency density. Okay, so they have said it is what? 7.5 centimeter tall. Which one? This class. This bar is 7.5 centimeter tall. Okay, for this class let's find out the frequency density. How much is this? 20 over what? 4. So 20 over 4 is what? 5. That means for 5 frequency density, now for 5 frequency density, height is how much? Height is 7.5 centimeter. Okay, so for 1 FD, what would be the height? Height is how much? 7.5 over 5 centimeter. Fine. So for how much? Let's see, the class for which the question asked for, let's find out the frequency density of that class. Okay, for that class, what's that class? 30 to 32. Okay, 30 to 32, this is 16. Frequency is 16 over 2, that is what? 8. So for 8 frequency density, what? Height is how much? Height is what? 7.5 over 5 times what? 8 centimeter. So what would be the value? 7.5 is basically 15/2. So 15/2 times 8, there is 4. So 60/5. So 60/5 is basically 12 centimeter. Okay, so 12 centimeter. Done. We got the height. Okay, so we got the width. How much? Width was 1.25 centimeter, and we got the height as how much? 12 centimeter. That's it. Done. Next, for part B, the question asked that using linear interpolation, we need to use linear interpolation to estimate the median of x. Okay, linear interpolation. This is an important part of this question. Linear interpolation, most of the student feels very difficult to consider the formula for linear interpolation, right? So let me show you a very easier way to consider that process, linear interpolation. So we need to find out the median. So right at first, for the median, let me show let me write you a very simple formula. Using that formula you can easily find out the median. That is, we need the Q2, right? Q2 equals to, use this formula, L plus n/2. Since it is Q2 the median, that's why it would be what? n/2 minus FC times h/FM. You don't need to write this formula in the exam, just use this sequence, this pattern. Okay, so L is basically the lower limit of the what? Of the median class. Okay, so this is L. n/2 you can understand. FC is basically the cumulative, okay, cumulative frequency to the what? To the median class, to the previous class of the previous class. Okay, of the previous class, to the median class. Okay, this is the cumulative frequency of the previous class of the what? Median class. And h is the class width, and fm is basically the frequency of the median class. Okay, frequency of what? Median class. This is the fm. So let's find it out easily. You can get it directly. Look, Q2. At first consider n/2. Where does this n/2 lies? Let's see. n/2, total number of data is 50. So 50/2 is what? 25. So where is 25? 2 plus 16, that is 18. 18 plus 20, that is what? 38. So that means the Q2, this is the median class. Okay, it lies, the Q2 lies here. So the lower limit of the median class is what? 32. The lower limit of the median class is 32. So 32 plus n/2 is what? 25 minus cumulative frequency of the previous class to the median class. This is what? 20. 2 plus 16, that is 18, right? This is what? 18. So n/2 minus 18 times h. H is what? The class width of the median class, that is 2, over frequency of the median class, that is 20. Am I right? Yeah, class width is 2, and class width is not 2, it's 4. Okay, class width is 4, and frequency of the median class, this is 20. Fine. So 4 over 20. So that would be what? 4 over 20. So what would be the value for Q2? So 25 minus 18 times 4 over 20 plus 32. So the value for the median, it's basically 33.5. what? 4. 33.4. This is the what? Median. Done. Okay, so what's next? Next is part C. Okay, next is what? Part C. For part C, they are asking, okay, they said the weight W grams of each of the 50 pebbles is coded. It has been coded using 10 y equals to what? W minus 20. These coded data are summarized by summation of y is given, summation of y squared is given. Okay, fine. So part C asks to show that the mean of W is 40.8. Mean of W is how much? 40.8. This is the concept from coding, that is from chapter 2, right? So for part C, at first let's find out what? Let's find out the mean for y. Okay, that is y bar. Y bar equals to what? Summation of y. Summation of y is how much? 104. Yeah, 104 over 50. That is 104 over what? 50. 104 over what? 50. So that is how much? This is basically 2.08. 2.08. Now we need the value for x bar. So just put this value into the coding formula. Okay, so the coding formula is 10y equals to 12 w minus 20. So 10 times y bar, so that would be what? 10 times, so 10 times y bar equals to what? W bar minus 20. So we need w bar. So w bar would be what? W bar equals to 10 times 2.08 plus what? Plus 20. So what would be the value for w bar? That would be 20.8 plus 20, that is 40.8. The w bar is what? W bar is 40.8. Okay, next they asked for what? The variance, right? No, this is in part D. So part C is what? 40.8. It has been showed. Okay, part D, calculate the standard deviation of W. We need to calculate the standard deviation of W. Okay, so the coding formula is 10y equals to W minus 20. So from there we can make the, if you make W the subject, what you will get? 10y plus 20. Okay, okay, so at first let's find out the variance. We can let's find out the variance of y. What would be the variance of y? The formula for variance is what? The formula for variance is sum of x squared over n minus the mean squared, isn't it? Okay, so this is the formula for what? Variance. And square root of variance is the standard what? Deviation, right? So let's find out the variance of y in part C. Let's find out the variance of y. So what would be the variance of y? This will be sum of x squared over n minus the mean squared, right? So sum of x squared, sum of y squared, sorry, it's y variable, so it should be y squared. So y squared is how much? 233.54. So 233.54. This is sum of y squared over n is what? 50, right? Minus the mean squared. What was the mean we got? This is 104 over 5. That's what? 2.08. Yeah, minus the mean squared. This is 2.08 squared. This is the variance of y. Okay, so let's find it out. So 23.54 over 50, this is basically 4.6708 minus 2.08 squared. It will give you 0.34 0.444. This is the variance of y. Okay, so y can be written as what? Y can be written as we got the equation for y is given as w over 10 minus 2, right? Okay, we should have made y the subject. Okay, if you have made y the subject, then you will get what? Y equals to 1 over 10 w minus 2. Fine. So y can be written as 1 over 10 w minus 2. So let's put it there. So variance of y is basically variance of 1 over 10 w minus 2. This is equals to how much? 0.3444. Okay, now variance of 1 over 10 w minus 2 can be written as what? 1 over 100 times the variance of w. This is equals to 0.3444. How? This is basically, coded formula, like the coding formula. So for coding formula, only for multiplication the variance gets changed. Okay, how it changes? It changes by the square of the multiple, right? So variance of w is what? 100 times 0.344, that is 344.4, isn't it? It's 34, no, it's 34.44. Yeah, 34.44. So this is the variance of w. So we need the standard deviation of w, right? So standard deviation is what? Square root of what? 34.44. So what you will get? This is basically 5.87. Yeah, variance is 5.868 something. So we can round it up to 3 significant figures, 5.868. It keeps going, so we can round it to what? 3 significant figures, that is 5.87. 3 SF. Okay, before rounding, how many decimal places they consider? 40.8. Yeah, 2233.54. Okay, 1 decimal place or 2 decimal place will do, no problem. Okay, so done. We are done with part D. We got the standard deviation, that is 5.87. That's it. Okay, next, the weight of a pebble recorded as 40.8 grams is added to the sample without carrying out any further calculations, instead giving a reason what effect this would have on the value of in part 1 the mean. Okay, the mean, what effect it will have on the mean. So the weight of the pebble of the new added pebble is 40.8, and we know that the mean, what was the mean weight? Yeah, mean weight was also the mean weight was, yeah, the y grams, right? Okay, y grams, w grams. Yeah, the mean weight was also how much? 40.8. So that means the new added pebble has the same weight as the mean of the whole data. That means adding this value into the data will not change the what? Mean. The mean will remain unaffected. Okay, so part 1 is that the mean will remain unaffected since the new data is equal to the mean of the whole data. Okay, so this is part D. This is part E1. Okay, mean will remain the same. Okay, since 40.8 is the mean of the what? Data. That's why. Okay, so part 2. Now for part 2 they asked like what it will impact, how it will impact the what? The standard deviation of W. Okay, let's consider one thing. Let's consider a concept here. This is a conceptual question. For standard deviation, what does standard deviation mean? Standard deviation is basically a measure of what? Measure of spread, right? So it represents the how the data values are spreading out, or how the data values are varying with respect to the mean of the data. Okay, so 40.8 is how much? The mean of the data was 40.8. so the new data that has been added, this is also what? 40.8, which is equal to the mean of the data, right? So since 40.8 is the same as that of the mean of the data, and standard deviation represents what? Considers the measure, the spread of the data with respect to the mean. So that means 40.8 is a value that lies within what? Within the standard deviation of the data, right? So the difference is what? The difference from the mean is 0. That means due to the addition of this data, the spread will increase. No, never. It will decrease, because 40.8 it is equal to the mean of the data, right? So that means there is no difference between the new added value and the mean. Therefore the measure of spread, that is the standard deviation, will decrease. Okay, because the data values are getting closer to the what? Mean of the data. Fine. So that's why the standard deviation of W will what? Decrease. Okay, because the value 40.8, it is equal to the mean, that is, it lies within one standard deviation about the mean. Okay, standard deviation will what? Decrease since 40.8 is equal to the mean of the data. Okay, if it is equal to the mean of the data, then what will happen? Data, so it lies closer, not, you can say closer to the middle of the data, that is closer to the mean, or you can say so it lies within one standard deviation, one sigma about the mean. Hence data values gets closer. Hence data values gets closer to the mean. That's it. Closer to the mean, and that's why the standard deviation of the data will what? Decrease. And that's all about question number 3 from May 2024 S1 paper. That's it.